Okay, so let's take a look at this problem. We have our bike, right? It has a tire diameter. So just like we did with kind of the previous, way back when in August, it's a good idea to kind of write down what you know in these problems. So let's go ahead and write down what we know, write down our givens as we solve the problem. So first of all, it says tire diameter of 70. So what do we know right away? The radius. Yeah, be careful when you're reading these problems. Sometimes they're going to tell you the diameter. Sometimes they're going to tell you the radius. Ultimately, you do want the radius. So make sure you're not just blindly plugging in numbers. You do want to convert it as well. Okay, constantly accelerates from rest. What is that telling us? Okay, the initial is 0. And what else is 0? Omega initial is 0. So, sometimes they'll be using linear terms, sometimes angular ones. If you're not sure, just say both. Okay, to a tire rotation rate of 120 revs per minute. What's that telling us? Omega final. Now, it's actually not telling us omega final, but it gets us there. Omega final is 120 revs per minute. However, we do need to make the conversion into what? Radians per second. Okay? So if you were paying attention earlier, what's the quick shortcut? 2 pi over 60. Okay, which is how much? 4 pi, all right. We want to leave it in 4 pi. You could leave it as 4 pi, or you could put it in decimal form. Either way is good with me. Okay, rotation rate of 120 in 10 seconds. So what's that? 10 seconds. Okay, let's start solving for things. What is the angular velocity of the tire? Well, we already found that, right? We found that as we were doing our givens. So 4 pi radians per second is our angular velocity. Let's find our angular acceleration. So we actually did this in an earlier problem, a slightly different way. Let's use one of our kinematic equations. Which one's going to work for us here?
WF equals WY plus AT.
Okay, so our omega final is 4 pi. Our omega initial was 0. Plus alpha, and what was our time? Was just 10, right? So what are we getting for alpha? 2, 6. So we'll just go to 3 digits. That's good. So that's going to be 1.26, and how do we write this? Looks good. Letter C, what angle does it rotate through in 10 seconds? So what variable are we looking for here? Theta, right? Specifically, well, delta theta. If the initial is 0, then just theta. So now we'll choose an equation that works for us, one of the 4. Let's try to use the one without that rounded number here. Which one would be good? Okay, that looks good. So delta theta equals 1/2 omega final that was 4 pi, right? 4 pi, or whatever decimal you used, plus 0 times 10 seconds. 60 what? Radians. Those of us that like to stay in pi, what are you getting?
It's 25.
Either way is good. How far does the bike move during this time? Okay, so what's the relationship between, we're looking for basically delta D or S. How do we find S if we know the angle? Multiply by the radius. So our radius was 0.35 times 62.8 or 20 pi. $22 meters. Is that confirmed? Okay, letter E. How many revolutions does the tire make during the 10 seconds?
10.
A, B, C, D, E. So this one, yeah, it's actually, keeping it in a pi term actually kind of helps solve this quickly, right? Because one revolution, what's the angle of one revolution? 2 pi, right? And so if we're going 20 pi, then how many revolutions must we have gone? 10 revolutions, yeah. So 20 pi, remember that's 20 pi radians, and one revolution is 2 pi radians. Now if it didn't turn out with such nice numbers, you would just do the same thing, 62.8 divided by 2 pi. Ten revolutions. Right, last question. How fast is it moving at its top speed? What's the velocity of this car at that top speed? How do we go from velocity? How do we go from angular velocity to velocity?
Multiply by the radius.
V equals R omega. Okay, so our omega, top speed omega was 4 pi. Okay, 4.4 meters per second.